Hello everyone. So we are going to start the part 7 of colloidal dispersion. So in this part we are going to discuss about the electric property of the colloidal particles. So without wasting any time, let's start. So the electric properties of colloid, if somebody make a discussion. So first of all we need to discuss or we need to have something in our mind is that, so you see the particles of the colloidal solutions, they are generally electrically charged. These colloidal particles are generally electrically charged and they used to carry the same type of charges. Suppose we have a group of colloidal particles, they will either have a positive charge or they will have a negative charge. So these colloidal particles generally they used to have a charge over the surface of the particle, and this charge is of same type. For a group of colloids, they will either have a positive charge or they will have a negative charge, but they never have a mixed charge. If they have a mixed charge, then definitely accumulation will take place or the agglomeration of the particle will take place. The next thing is that the colloidal particles, thus having the same charge, they used to repel each other and they never cluster, or you can say they never agglomerate and they settle down. Thus they have the property or they have the stability. The charge on the colloidal particle, it arises actually due to the dissociation of the molecular electrolyte on the surface. I repeat, the charge attained by the colloidal particle, the charge attained by the colloidal particle over their surface, it is due to the dissociation of molecular electrolytes. Molecular electrolyte means the electrolyte which is present in the dispersion medium that will get dissociated, and the charge of the molecular electrolyte will be eventually distributed over the surface of the colloid. For example, if you take the example of As2S3, that is arsenium trisulfide, it has a negative charge, right? So you see, during the preparation of the colloidal solution of arsenium trisulfide, the hydrogen sulfide, it is present, it is needed, so it is present. This hydrogen sulfide, it actually get absorbed on the surface of the colloids of the arsenium trisulfide, and once this hydrogen means dihydrogen sulfide, once this dihydrogen sulfide it is absorbed on the surface, it immediately dissociate the hydrogen or the proton. It is the proton, it is lost from the hydrogen sulfide, the proton it is lost to the medium. Thus you see the proton it is lost to the medium, so the medium it is attaining a positive charge, while the sulfide it will remain over the surface of the colloid, and this sulfide will give a negative charge over the colloid. The positive charge of the hydrogen it will go to the medium, whereas the sulfide it will give the negative charge over the surface of the colloid. Here, so this is how it looked like. You see, these are the particles. This red color, these are the charge over the colloidal particle. Similarly, for example, if you take the example of iron oxide, it is positively charged. Due to the self-dissociation and loss of one hydroxyl group to the medium, this iron oxide particle or the colloid of the iron oxide, they are always positive. The iron oxide, they are always positive because the iron oxide, they lost one hydroxyl molecule to the medium. Thus the medium, the dispersion medium have the negative charge, and the colloid they will have the positive charge. The next concept, it is the electrophoresis. So we all know that what is electrophoresis. It is the most known electrokinetic phenomenon, right? So what is there? We generally used to apply a electric potential difference across a colloidal suspension. So it refers to the movement, the electrophoresis refers to the movement of the charged particle related to the fluid under the influence of an applied electric field. So if the if an electric potential is applied to the colloid, the charged colloid particle they will move toward the oppositely charged electrode. Suppose we have a solution of colloids. This colloid particle have negatively charged or they have negative charge over the surfaces. If we apply electrode two electrode in towards the end of the colloidal particle, then what will happen? As the colloids have the negative charge, they will always migrate toward the anode. They will always migrate toward the anode. The next concept, it is the electro-osmosis. So what is electro-osmosis? So this is a general model. It is known as the model of water and salt movement by electric field. We will discuss here. See, the electro-osmosis, it is a principle which works just opposite to that of the electrophoresis, number one, right? Number two is that you see what happens actually when we put the electrode across a clay mass. Suppose this is a clay mass, right? Clay mass. So if we put the electrode across a clay mass, a direct current is applied. This is a dispersion medium, this is a clay mass, and two electrodes are applied. One, it is the anode with a positive charge, this is the cathode with a negative charge, right? Now what actually happened here, the water in the clay pore space, it is transported to cathodically, and the charged electrode by electro-osmosis. So water in the clay, you see how what happened actually, the water it get dissociated, right, in the anode side like this. Here the water is in the cathode side like this. So this is the mass flow. So sodium ions is generally remain present. If it is present, this sodium ion actually helps to attain the positive charge. Thus you see the water it generally passes through this clay mass. So electro-osmotic transport of water through the clay, it is a result of diffuse of the double layer cation. I repeat, the electro-osmotic transport of the water. I repeat, the electro-osmotic transport of the water through the clay, it is a result of the diffuse double layer cation in the clay pores being attracted to the negative charge electrode, or you can say cathode. It occurs due to that a water molecule will come towards this cathode, as because the water molecule, they will attain or the sodium above them. The sodium, they are having the positive charge, and thus the water, by virtue of the sodium present, the sodium as it is having a positive charge, it will be migrated towards this cathode via this clay. As these cations move towards the cathode, they bring with them the water molecules that clump around the cations as a consequences of their dipolar nature. So this is the electro-osmosis. The next concept, it is the sedimentation potential. So what is the sedimentation potential? We all know that we have discussed the process of sedimentation. The sedimentation, it is the settlement of the particle by virtue of an external force, right? So the concept of the Donen membrane equilibrium will come now. So you see the sedimentation potential, it is also known as the Donen's effect. Now it is the potential, this sedimentation potential, it is the potential induced by the fall of a charged particle under the external force field. Suppose we have the colloidal particle. Now this colloidal particle, if we allow this colloidal particle to fall under the influence of an external field, then this colloidal particle will create potential difference, that is known as the sedimentation potential. So it is analogous to the electrophoresis in the sense that a local electric field is induced. Here a local electric field will be induced as a result of its motion, right? So if you again see, if the colloidal suspension has a gradient of concentration, if the colloidal suspension have a gradient of concentration, if they allow to fall under the influence of an external field, then definitely they will create two poles. You see, excess positive charge will be here and excess negative charge will be here. Thus then the microscopic electric field is generated by the charge imbalancing appear at the top and bottom of the sample column. So here, if you allow the colloid particle to fall, here you see excess positive charge will be there, here excess negative charge will be there, and this movement of the colloidal particle is due to the virtue of the external field or external force that we have allowed. The next concept, it is the streaming potential. It is nothing but you see steaming potential is differ from the electro-osmosis. In that, actually what happens, the potential is created by forcing a liquid. Here colloids will not go. Steaming potential means the potential it will be created by forcing a liquid to flow through a bed or plug of particles. If we allow the liquid to flow through a bed or a plug of particle, a potential will be created. This concept it is known as the steaming potential. I repeat, if we allow the liquid to flow through a bed or plug of particles, a potential will be created, which is known as the steaming potential. So thank you everyone for your patience hearing. If you like the video, just press the like icon. You can share this video. Moreover, you can subscribe to my channel. Thank you once again.